So let's look at another example. This one involves tangent. Tangent, as we look at the sum difference formula, is a little bit more involved, and so I want to walk you through this. The big reason is because at the end we'll usually simplify it, and that's where I'll see some people get hung up. So find the exact value tangent of 165 degrees. So again, I want two angles from my unit circle that either add or subtract to make 165. Now again, there may be certainly more than one combination. Sometimes there's maybe a lot. For this case, 165, the easy ones that jump out to me is if I do 45 plus 120. That would make 165. So that's what I'm going to do. Okay, so let's go ahead and set this up. So tangent, let me get my pen going here. So tangent of 165, what we're saying is that's the equivalent of tangent 45 plus 120, right? So this is going to be my alpha, this is going to be my beta if we go ahead and apply the formula. So I've got tangent 45 degrees plus tangent 120 degrees all over 1 minus tangent 45 degrees times tangent 120 degrees. Again, I'm just using the formula there, just plugging things right in. Okay, now let's substitute these values. Tangent of 45. Here's a nice thing about this unit circle I gave you. It's got the tangents right on here. So that's just 1. Tangent 120, if we go find that, well, it's actually a negative root 3. So 1 minus root 3 all over 1 minus, now tangent 45 was just 1, times negative root 3. So notice what we get. So we've got 1 minus root 3 over 1 plus root 3. Now, that's kind of an ugly looking answer. We've got radicals in the denominator, which I've told you before, that doesn't offend me at all. So, you know, this would be okay to leave our answer, but most of the time when we work with tangents, they're going to simplify these. So let me just show you how they would do that. The way we would get this radical out of the denominator, we're going to multiply by its conjugate. So I'm going to multiply this whole thing by 1 minus root 3 over 1 minus root 3. The conjugate, just change the sign there, right? And that should be pretty familiar. So let's multiply the top out. In fact, maybe to help us visualize this, I'm going to put parentheses around these. Just help you. So make sure you distribute everything. So 1 times 1 is 1. 1 times negative root 3 is minus root 3. Now I'm going to take my root 3 through everything. So negative root 3 times 1. So minus root 3, and then negative root 3 times negative root 3. So that's going to be plus 3. And then on the bottom, we're going to get 1 times 1 is 1. Now 1 times negative root 3, so I'll go ahead and show it here. Minus root 3. Root 3 times 1 is plus root 3. Notice those are going to cancel. That's what the conjugate does for us. It's going to get rid of those radicals. And then root 3 times negative root 3 is going to be minus 3. Alright, let's clean this up. So on the top we've got 1 plus 3, that's 4, minus root 3, so minus 2 root 3. On the bottom here, alright, so we've got the top here, 4 minus 2 root 3. Now on the bottom, let's go ahead and combine things. So 1 minus 3 would make, where's my pen at? So 1 minus 3 would be negative 2. And then notice negative root 3 plus root 3. That goes away. That's what the conjugate did for us. Now notice, so I can simplify this just a little bit more. I could divide all these by negative 2. And so if I do that, 4 divided by negative 2 is going to be negative 2. Negative 2 root 3 divided by, negative 2 is just going to be plus root 3. So I could write that as root 3 minus 2 or negative 2 plus root 3. Fine either way. And if you go plug this in your calculator, so if you plug this guy and this guy, they're the same thing, but notice this does look a lot nicer. It's a lot simpler. So that's usually what's going to happen when we work with tangent. They'll multiply by the conjugate. just to clean it up a little bit.